and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
I'm Isaac, and I'm Internet Math League, and I'll show you how to do the last problem of sprint for today. Sally wants to sort the list 7, 6, 5, 4, 3, 2, 1 with a sequence of moves. Each move, she chooses two different numbers A and B in the list, where A is to the left of B, and A is greater than B. That is, A and B are out of order, essentially. Then she removes B and inserts it directly to the left of A. Let M be the minimum number of moves that Sally is required to make, and let N be the number of ways that Sally can make a sequence of M moves. That sorts the list from least to greatest. And we want to compute the sum of the digits of this sum N plus N. Okay, so let's go ahead and find M and N. Firstly, we need to find the smallest number of moves it takes. So what does it take to sort this list? Well, 7 is out of order relative to each of 6, 5, 4, 3, 2, and 1, and each move only moves one of these numbers to the left of 7 at a time. So we need at least 6 moves to move each of these numbers to the left of 7. But you can see how it's pretty easy to do this. You can just, for example, take each of these numbers in order and then just move it to the very left, since each of these numbers are just going to be greater than the last. So for example, if we took a sequence 7, 6, 5, 4, 3, 2, 1, an example of a 6-move sequence that moves all numbers to the correct order is moving the 6 over. So 6 moves directly to the left of 7. Then we choose, say, 5 and move that to the left of 6. So it goes to the very left, since 6 is greater than 5. And we can keep on doing this. Okay, so this method will give us 6 moves. And so that will be our M. Okay, how many ways can Sally make a sequence of M moves so that the list is sorted? So there might be multiple ways to sort this list in 6 moves. Well, here comes the other observation. Note that when we start out, we could just move any of these numbers to the left if we wanted to. And there's only one space to the left that we could move these numbers to. So at any given point, where can we move these numbers and what numbers can we move? So let's say we can do this 3, for example, and move it to the left as well. So we would have 3, 5, 6, 7, and 4, 2, and 1. Okay. So given any collection of numbers that are still on the right, we have numbers on the left as well. And note that these numbers must always be in sorted order. Because if at any point they weren't in sorted order, once we move all of the numbers from the right of the 7 to the left of the 7, that would take 6 moves, but the numbers wouldn't be in sorted order. Therefore, these numbers on the left must always be in sorted order. Okay, now consider any number that we pick from here. You can like pick 4, for example. Can this always be placed to the left of 7 somewhere? Well, yeah, we can just place it in the correct order relative to this. So for example, the 4 would go here. However, there's exactly one place that we can place it in a relative order to any list. So if you just were to pick any number and then insert it into a sorted list so that the list remains sorted, there's exactly one place you can insert it. So it turns out that for every number here, there is exactly one way to make a move so that this list on the left remains sorted. And so it just comes down to picking which numbers to put to the left first. So at every given point, if there are some number of numbers on the left, say there are A numbers on the left, at any given point, then the number of ways we can move a number from right to left using one of these moves is going to be A ways. And note that this size of the list decreases by 1 each time we make a move. So the total number of ways is just going to be 6 times 5 times 4 times 3 times 2 times 1, which is 720. So that's our n. Finally, we just compute this. This is going to be 720 plus 6 equals to 726. And the sum of the digits is going to be 7 plus 2 plus 6 equals to 15.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.